Hey everybody, I hope you had an enjoyable weekend. Today we are going to start working on section 2.5, which is similar shapes. Before we get started with that, this is a little bit of background information that hopefully you guys remember how to do. If not, this is kind of a quick reminder. We have to find out if the ratios form a proportion. So if you remember, proportions mean that the two things are equal. So the ratios are referring to the fractions. And so they're asking, are these fractions equal to each other? So there's several different ways you can go about doing this. One way of doing it is you can simplify both the fractions and see if they simplify to the same thing. So for instance, 2/5 and 10/25. Well, 2/5 is already simplified. 10/25, 5 goes into both of them. 5 goes into 10 twice. 5 goes into 25 5 times. So that would also be 2/5. So that's one way of knowing that these two things are proportional. Another thing you can do is you can cross multiply. Now, sometimes with these especially, the numbers might get quite large. So if I have 7/14, I have to find out, well, does it equal 21/28? So what I would do for this is I would cross multiply. So I would do 7 times 28, which would give me 196. And then I would do 14 times 21, which is, I'm going to have to bring this up, I don't know, 14 times 21. I could do it, but we got calculators, right? 294. So does 196 equal 294? No, it does not. So these two do not form a proportion. All right. So if you want to try these out, pause it and try them out on your own, and then just resume when you're ready. And I'm gonna go ahead and start them. I prefer the simplifying method the best. So for this one, I have 12/21. 3 goes into both of them. 3 goes into 12 4 times. It goes into 21 7 times. 15 and 30 simplifies to 1/2. So those do not form a proportion. And this one here, again, 3 goes into both of these. So that'd be 5/8. 35/36. That's as simplified as that gets. Nothing goes into both those. So again, that'd be no. Alright, so that's how you find out if things are proportional, and that's very helpful for what we're about to do with similar figures. Similar figures, one way we can tell that figures are similar is what it means basically is that they have the same shape but not necessarily the same size. So these triangles, I know that they're both triangles, but that doesn't make them similar. What makes them similar is that the angles are exactly the same. So if the angles of the triangles are exactly the same, they're going to be similar. It's going to make them exactly the same shape. They're not talking about triangles in general when they say shape. They're talking about like the angle measure of the triangle. So for these two triangles, they are similar because if you notice, this angle is the same as this angle, B is congruent to E, and C is congruent to F. So these two triangles are similar but not congruent. The reason they're not congruent is because their side lengths aren't exactly the same, but their corresponding side lengths are proportional. Okay, so the corresponding side lengths are proportional, meaning that if I put BC over AC, so the side length of BC over the side length of AC, it would be equal to the ratio of EF over DF. So the angles are congruent, but the side lengths are proportional. And so we'll see that here. We have what we were just talking about right here. Now you'll see that these are different, the way that they write them. They said AB over DE is the same as these, which is also true. So if I said this over this, it would be the same thing as this over this. So there's different ways to write the ratios, but if you just keep them consistent with the way you're going, that will be proportional. So we'll start off with an easy example, just which rectangle is similar to rectangle A. So for rectangle A, if we take the short side and put it over the longer side, and we simplify that fraction, we would get 1/2. So we need to know, is the ratio of the side lengths of the shorter side or the longer side for either one of these rectangles equal to 1/2? So this would be 2/6. 2/6 is 1/3. So that would be a no. And this would be 2/4. 2/4 would be 1/2. So that would be yes. So rectangular A and rectangular C would be similar. So the way we do that is A is similar to C. The sign here means similar. If we go back, we'll see that they have that here. So they said ABC is similar to DEF, so that's kind of the what we have there. I mean, you could say rectangle A and rectangular C. Usually you would write out the whole words. My writing, as you can tell with this, is not too great, so I would just butcher it anyway. So rectangle A is similar to rectangle C. So now for this example, they tell us that the triangles are similar, and they're asking us to find a missing side length. So we can set this up several different ways to solve for x. Since we know they're similar, we know that the ratios are proportional. So we know that if we put 6/8, it would be equal to, well, this is 6, this is 8. So 6 goes with 9. Those are the corresponding sides. So since 6 is on top, 9 would go on top, and x would go on bottom. So that's one way to set up the ratio. Another way we set up the ratio, since 8 corresponds with x and 6 corresponds with 9, we could say 6/8 equals 8/x. So that's another way we can set up our ratios to find the answer. So at this point, all we would do is we would cross multiply. So 9 times 8 is 72, which equals 6x. And you don't have to do it both ways, but if you chose to solve it this way, you'd get 6x equals 72. Notice they're exactly the same. That's why you wouldn't have to do it both ways. You're going to get the same answer when you do this. So if I divide both sides by 6, I get x equals 12. So 12 meters is the length of x. And obviously this one would also be x equals 12 meters. So, you can set up the proportions in different ways. You just have to be consistent with how you're setting it up. So if you're doing, on the same triangle, 6/8, make sure you're doing 9/x. If you're doing 6/9, make sure you're doing 8/x. You could have also done 9/6 equals x/8, or 8/6 equals x/9. All of them would have given you the same answer. You just have to stay consistent with your ratios. So why don't you do me a favor and try these two out on your own. Pause the screen, try them out, and then in a second turn it on again and watch me do it together, and we'll see if we have the same answer. So just pause the screen and give it a shot. Alright, and hopefully we're all set now. So what we're going to do now is I'm going to say, I'm going to do this one over this one. So I'm going to say x/6. You might have done this a different way, but hopefully we get the same answer. So x/6 and then 6/9. And then if I cross multiply here, I get 9x equals 36. And if you divide both sides by 9, you'd get x equals 4. So x equals 4 feet. Alright, now for this one, I'm going to choose to do x/14. And if I was doing x/14, it's like I'm doing the bottom one over the slanted one. So I do the bottom one, which is 12 on top with the x, because that's what corresponds with it, over the 7. And then I would cross multiply from here. So 7 times x would be 7x. 14 times 12 would be 168. And when I divide both sides by 7, I would get x equals 24 centimeters. Alright, so that's how we use the fact that these two shapes are similar to find out missing side lengths. We set up the proportions, and then we cross multiply to solve. Alright, so that's what we're going to cover today. So there's going to be a couple problems on big ideas for you to do. As always, if you have any questions, please write them down in the Google Doc. If my answer or someone else's answer is not good enough, please reach out to somebody for some one-on-one extra help. Alright, so make sure you're utilizing those resources. Alright guys, good luck with everything and have a great rest of your day.